Information security risk management is about supporting decision-making under uncertainty. There are two approaches can be used to handle uncertainty. One is modeling approach, or called modeler's approach. Some well-formed modeling can help us figure out what good metrics ought to look like. This is a top-down approach that defines security metrics from the point of view of the modeling threats, risk, and losses, and asking questions like why things happen, using risk equation, loss expectancy, linear algebra, economic incentives, and so on. It is similar to the mindset of scientific theorists that define the hypothesis or the model first, and then design the experiments and collect data to prove the hypothesis. Another approach is data-driven approach, or called Measurers' approach. It is a bottom-up approach and is similar to the mindset of experimentalists and purely driven by observations and empirical data, and then apply time series analysis, correlation analysis, for example, to derived metrics. What constitutes the good matrix then? Good matrix should be consistently measured without subjective criteria. For example, metrics versus ratings. Ratings are subjective to human judgment, which are often not repeatable nor consistent. Good metrics are cheap to gather in terms of time and money, preferably in an automated way with short sampling intervals. The table here shows some examples security metrics can be used for security management decisions in operations management, program planning, strategic planning, crisis management, based on the measurement frequency and importance of the measurement. For instance, metrics with high frequent measurements and relative low importance, such as anti-malware data, network operations and traffics, security operations, maintenance or housekeeping. This matrix can be used for operations management decision-making. Matrix with a high frequency measure and a relatively high importance, such as threat metrics, intrusion detection. This matrix can be used for crisis management decision-making. So please read examples listed under strategic planning and program planning offline. Furthermore, good metrics are expressed as a cardinal number of percentage, not with qualitative labels like high, medium, or low. They are expressed using at least one unit of measure, such as defects, hours, or dollars for benchmarking purpose. 2 units of measure are better. For example, number of application security defects per 1,000 lines of code. Metrics with short sampling intervals help companies analyze their security effectiveness on a day-to-day and week-to-week basis rather than through a whole year review. They are contextually specific, relevant enough to decision makers so that they can take actions. For instance, scoping the average number of attacks down to business unit to make specific decisions about security provisioning and staffing, rather than using the general average number of attacks. Good metric ought to pass this smell tests. So, what are the bad metrics example? Bad metrics are often vague and confusion. They are inconsistently measured, such as ratings-oriented metrics. They are very useful for taking organizations' temperature, but they are not good metrics. Bad metrics cannot be gathered cheaply. We often call them expensive metrics. For instance, for metrics that are more operational or diagnostic in nature, long sampling intervals will not cut it. Bad metrics do not express results with the cardinal number and units of measures. For instance, subjective scores, numerical equivalents, are functionally equivalent to ratings. So what are not metrics? ISO 17799 defines a structured approach to framing and addressing the problem space of information security. It provides an excellent lens for viewing the subject of information security. It carves the security problem space into a taxonomy of 10 subject domains ranging from security policy to physical policy, access control, and system development. These subject domains break down into about 150 control areas. There are many so-called metrics projects focused on subjective assessments against an established taxonomy. Self-assessment tool designed to quantify risk based on the ISO standard and AOE method. ISO 17799 is a well-structured security taxonomy and is often used as guidelines for assessing compliance with good industry practices. But it is not a metrics framework, since its excessive focus on audit, such as security control requirements, but no practical recommendations, and it contains subjective success criteria, even though they are highly descriptive but rarely prescriptive, and it pays insufficient attention to measurements. AOE model the impact that security events have on asset. The numbers used in AOE are not metrics.